right, so today's lesson activity is called A New Way to Measure Angles. Now, let's talk about distance. What is one unit that you can measure distance? Say again?
A meter.
A meter, great. So this is about a meter. What is another way that you can measure a distance, another unit?
A yard.
A yard, okay. And let's do one more.
A mile.
Mile, okay. Let's think a little bit smaller, something that was, okay, inches, okay. So many different ways we can measure length, okay. What about feet? Just kind of go with this. Okay. So you've got, this is actually right here, it's a little bit more than 3 feet, so, but we'll round it. Say this is about 3 feet. It's a meter stick, not a yardstick, so. And it's also 1 meter. So 1 meter, and it's approximately 3 feet. Now, the reality of the thing is this length right here. The units have different symbols here, and notice also the number that's in front is a little bit different. We've got a 1 over here, and we've got a 3 over here, okay? What we're going to do today is we're going to find out how do we traditionally measure the size of an angle?
In degrees.
In degrees.
Oh.
This would be like X degrees. What if I told you there's another way to measure the angle?
I'm sure
you might be like, okay, that's interesting. So the reality, the angle is still going to be the angle, just like this is still the length, okay? But we're going to have another unit, and that's what we're going to talk about. So, a new way to measure angles. You've got your circle, you've got your center. Let's go ahead and measure the radius of that circle. In centimeters, please. And write it there along the radius. Mine is about...
You want to like draw the line?
Yeah, go ahead and draw a line. That'd be great. Mine's about 22 centimeters. Ooh, nice creative use of this. Also have this you can trace. Who needs a bit of string?
You're reading.
You have a circle? You have a circle. Make a circle.
Me.
Yep, everybody. Everybody in the class, make a circle. Good, you measured it? Alright, I like it. There you go. Alright, when I point to you, tell me what's your radius here?
9 centimeters.
Let me think. Alright. Shout out, what numbers do you have for your radii?
6.
3.5, 4, 6, 7. Nick, what do you got for your radius? 5. Okay. Mine's 22. But I've got a pretty big sheet of paper up there. So what I want you to do is imagine with me, so eyes up here for just a moment, then I'll let you get back to measuring your radii. Imagine if there was maybe some sort of ant, started at the center, and he walked all the way there to the edge. He would have walked 22 centimeters. Then he decided to turn and walk along the edge here. It's a curve, but that's okay. He's still walking, all right? And the distance that he's going to walk is also 22 centimeters. Okay? Then it's going to stop right there. Now what I want you to do is to find out with the equipment that you've been given, where is that ant going to stop along your curve? So I want you to measure 22 centimeters along that. Oh, you would,
Our
sorry,
own
your
radius.
radius. Your current radius. Anybody have an idea how we're going to do that?
No, not in slightest. I don't know.
Maybe we could be like,
Right. That's what I was about to do. Like, oh,
it's not the
right.
straight line path, that's going to be too short, you know? Any other ideas with the equipment you've been given?
That's actually really smart.
What do you got? What are you doing?
Well, this might be stupid, but like measure out however many like centimeters on your string and then just curve that along your.
Yeah, sure. In fact, you don't even need to measure it. This is what I would do. Go ahead and put that string there and just make it the exact length. Then keep this one pinned here and just kind of, you might need to have a partner here. Mine's vertical, so we'll do.
Oh, so you have the right angle.
And so then let that string kind of go along the edge and then see where it stops. Put a nice dot there at the end. And then go ahead and connect those dots. I want to figure out what that angle is right there.
Oh, it looks like a piece in here.
Alright, so draw that angle, that central angle, because it's going by the center.
Can I draw a point along it?
Sure, and then I want you to measure it. Wow, that's pretty darn good, not gonna lie. And so measure that angle in degrees, because we don't know the new way yet. Measure that angle in degrees and tell me what number you have. Alright, let me go around and check those numbers.
I don't know if it is.
Let's go, let's go, let's go. Okay. That's in the ballpark. What's your angle there? It's a little low. Yeah. That looks a little bit more, it's kind of ballpark. Yep. Oh, y'all are just rounding. Did you get really 60? Or is it just a
Yeah.
little bit above or a little bit below?
I got exactly 60.
What are you getting, Robbie? Okay, I like that. It's a little bit off there. Okay, okay. All right.
I did it right.
Where's that red pen? All right. Robbie, what'd you get?
63.
63.
Good job.
Nia.
Oh, I got 60.
Ashley.
62.
Mason.
57.
Haley.
Oh, 60.
Haley.
60.
Nick. Jeremy.
60.
And Stephanie. All right. But you all had different sized circles, right? Now the fact that some of you had large circles, some of you had small circles, and yet these all kind of seem to be sort of hovering. I'll be honest with you, that 50 number, that's an outlier. I'm not sure what's going on with that, Nick. But kind of looks like it's around 60, right? Okay, I'm not going to tell you if it is or not. There is an actual exact answer that works for all of ours. Okay? Are you ready for it? I think I will tell you. Here is that angle. That angle is 1 radian. 1 radian. It is a new way to measure angles. Really felt sort of like an old school math teacher there. All right. So 1 radian. So you might say, well, what's a radian? And I would say It is the central angle formed by an arc that is 1 radius long. And it doesn't matter if you have a teeny tiny circle or a really big circle, all right? You know, however big that circle is, that radius, if you take that radius and move up along the arc, then you will form an angle that is 1 radian. All right? Now, how much is a radian in degrees? That's the big question. Who's right? Who's the closest? Let's find out together. You might need another sheet of paper here for us to continue this on. Sort of our ways. This is radians and degrees. That's sort of the title of today's lesson. A new way to measure angles, the radian. Now, someone was asking my earlier class, they're like, so a radian is different from a radius? And I said, yes, it is. The radius is the length from the center to an edge. A radian is the angle formed by an arc length of length equal to the radius. So we have R here. We have a nice arc. And that arc length is R. And then we have this angle, which I might as well put an R right there. And theta right there. And as we said, theta equals 1 radian.
So we don't draw a purple circle right now?
No, just freehanded. So here's the question. How many degrees equal 1 radian? Is it 60? Gosh, that'd be nice. It's a little bit above 60, a little bit below 60. Why is it a little bit above or below? Why can't it be 60? That'd be so nice. Maybe it is 60. Well, rather than just tell you what the answer is, I'm going to show you, because that's kind of what we do in pre-cal. I'm going to freehand another circle here. Maybe a little more. You go ahead and do this too. I wouldn't really expect you to be able to figure out on your own what that relationship is, but I would expect you to be able to follow along with this thought process here. So that's R. I kind of go up along here. That's also 1R. And like I said, this is 1 radian. I'll abbreviate it rad. It is, actually. All right, so what we're going to do is we're going to walk around this circle here. So there's another rad. There's another rad. Radius length there, radius length there. There's another rad. I'm just trying to make these about the same length. 1 rad. I got a little bit more action here. So I'm looking at this. This is me trying to sort of eyeball it here. 1, 2, 3, 4, 5, 6, plus a little bit of change there. Okay, so it's. Now, talk to me about going all the way around the circle. What measurement is that called? It is the perimeter, but with the circle it has a special name. Circumference, right. So the circumference, now there is a formula for the circumference. I heard pi d.
Or like
Or
2 pi r. Or I mean not pi squared. That's
area.
pi r squared is the area. 2 pi r is the circumference, and that 2 and the r come from the fact that the diameter is just 2 times the radius. So those are totally equivalent. Okay. So the way that we're going to kind of set up this problem to figure out how many degrees equal 1 radian is using that old friend proportions.
Wow.
All right? It's just that simple. What we're going to do is we're going to set up proportions so we've got the angle in the numerator and the arc length in the denominator. So we'll kind of do like small angle, small arc length equals big angle, big arc length. So here we go. 1 rad, that's the angle, over the arc length. What's the arc length right here? How long is that arc length? Say it again.
3.
Nope, this guy right here.
Oh.
So 1 rad is the angle. The arc length, boys, what do you think? What's his arc length? It's listed right there in a letter, Nick. It's radius, yeah.
You said that. I
Why
thought I
didn't-
said that.
Well, maybe I didn't hear you. That's small angle over small arc length equals big angle. So start here, go all the way around, full circle. How many degrees is that? Haley? She's got it, 360. Over big arc length. That's the big arc length, which is the circumference. So 2 pi r. Let me say this again. I would expect you to sort of figure this out all on your own, except unless you had like a whole bunch of time and were seriously motivated. But I do expect you to follow along with these steps. That is, we know this, and we know the proportions that, you know, how to set them up. Small angle, big, or small arc length, big angle, big arc length. Let's figure out what this 1 rad is. We're going to multiply both sides by r to get rid of this r in the denominator. So 1 rad, that's 1 radian, is equal to 360 degrees over 2 pi r times r. Multiply both sides by r. When you do that, you'll notice something beautiful happens over here on the right-hand side. The r's cancel. That's why we're going to get the same answer no matter how big or how small your circle is, no matter what the radius is. And so here we go. Oh, I should have told you to get calculators. Now everybody's going to walk over and get a calculator. That needs to be part of your standard procedure. You walk, get a calculator, walk and go. 360 divided by 2 pi. Let's figure out who's the closest. This is it. This is our answer. How many degrees equal 1 radian? 360 over 2 pi. Calculators go. What do you get, Nick? He doesn't like what he's saying. What do you get, Stephanie?
565.
Lies. Your calculator's lying to you. Also remember your order of operations. You probably typed in 360 divided by 2 times pi. That is not what is shown here. This is showing that 2 pi is in the denominator as a product. This is going to be 360 divided by 2, which is 180 times pi, which means 5 something. That's not right. We want 360 divided by the product of 2 times pi. Go ahead, Mason.
57.3.
Aha! Who had 57.3, kind of, sort of? Was that you, Mason? Good job. That's the most accurate. That, this is an approximation, but there you go. 1 radian, 57.3 degrees, approximately. In all honesty, though, if we are going to be doing approximations, you might as well just round up to 60, because we can kind of eyeball it that way. Okay? So if everyone asks you how much is 1 radian, you could say, well, it's the measure of the central angle formed by an arc length of radius, or you say it's about 60, or more precisely about 57.3 degrees. Okay? So this is a new way of measuring angles. That's 1 radian. Okay? If I were to say, have 2 radians, that's about a 60 plus another 60. So it's somewhere kind of like that. That would be 2 radians, roughly. A 60 and 60 is 120. 120 looks about something like that. You see where I'm coming from? So it's really weird that it's you're like, that's 2 radians. What's a radian? A radian's about 60 degrees. A little bit less, okay? So there you go. How many degrees equal 1 radian? 1 radian is approximately 57.3 degrees. That's okay sometimes, but in reality, I'm going to go back a step here. 1 radian equals 360 degrees over 2 pi. We normally don't talk about radians with decimals, okay? We normally use some other ways of talking about radians. So let me show you how we do this. I'm going to multiply this equation right here. This is just right back where we had it a minute ago before we did the division. We'll multiply both sides by 2 pi. So that we have 2 pi times 1, which is 2 pi. 2 pi radians equals 360 degrees. This is actually a way of talking about radians that we use a lot more. 2 pi radians is 360 degrees. So that means if I'm, going skiing or snowboarding, and I hit a jump, and I spin around, and I'm still back the same way, you would normally say, whoa, he just did a 360. But you would be equally and more nerdily correct if you said, whoa, he just did a
2 pi rad.
Yeah. No, you'd be like, whoa, he just did a 2 pi. And she would say, that's rad. Right? Okay, something like that. All right? So yeah, there you go, 360 all the way around. We could write that as 360 degrees or 2 pi radians. Now, why are you writing it 2 pi? I mean, couldn't you write like 2 times 3.14, so like you could write it like 6.28 radians? Okay, yeah, you could, but this is much more exact. In fact, if you remember when I kind of was doing this, I knew the end in mind, so I had like 1 radian, 2, 3, 4, 5, 6, plus a little change. That's the 0.28 right there, radians. All right? So another common way that we deal with radians is we actually take this equation right here and divide it by 2 on both sides. So 2 pi divided by 2 is pi radians equals 360 divided by 2. What's half of 360? 180.
I was like, I know this one.
There you go. Pi radians is 180 degrees. We use that one. That's almost the one that I really like. So, once again, friends going on their skateboard, they hit a wicked jump, and they'd be going the opposite direction. That'd be kind of weird. Maybe you're walking, having a certain lifestyle, but then you make a change. You say, whoa, that person has done a complete 180 or done a complete pi, right? Yeah. Anyway, so you can say that's 180 degrees, or that is pi radians. It's about 3.14 radians. Like I said, about 1, 2, 3, plus a little bit of change there. So radians are just another way of talking about angles. Remember what we said at the beginning, okay? The reality of this is this long, okay? I could write it as 3 feet, or I could write it as 1 meter, okay? The reality is the same. I've got different symbols over here that I do over here, and actually a different number over here as I do over there. Same thing going on here, where I say, I've got a different number here than I have a different number here, and I have different units here, and I have different units here. However, the reality of it is the same. This is the reality. This is the angle. If I try to get confusing, I could say, how do we measure temperature? Degrees, okay? Degrees Fahrenheit or degrees Celsius. right? So if I were to say it's 100 degrees Celsius, anybody know how many degrees Fahrenheit that is?
212.
Say again?
212.
Yeah, 212. She remembers. Water boils. The reality of it is it's really stinking hot and that water is boiling. Okay? But we could have different units, different ways of talking about it. And when we have different units, we've got a number over here that's different from the number over here. It's the same way with radians and degrees. 180 here, and then pi. Pi is a number just like anything else. Okay. Let's keep this going. This is a fun party here. Let's cut that in half again. Divide this side by 2. So pi divided by 2 radians equals 180 divided by 2, 90 degrees. So you're telling your friend, you're driving down Main, and then you make a 90-degree turn on Nolan River, whatever, I don't know. Okay? Or you could say, go down Main, you make a pi over 2 turn to the right. They'll be like, what the heck? Math class. So there you go, pi over 2, that's another way for 90. Let's keep going. Anybody know what would happen if you take pi over 2, just think of it like 1/2, and cut that in half? So think of it like this. There's a pi multiplied by all this, but who cares about pi? Just think of it like 1/2. What's 1/2 if you cut half and a half? What do you have left?
Yeah.
We got Jeremy. Half of a half. 1/4.
I was thinking multiple.
So I'm gonna write that as, I'm not gonna write the 1, but pi over 4. So pi over 4 radians is 90 divided by 2, 45 degrees. I always kind of remember that because of the 4s.
Oh.
And that's actually a special angle. Speaking of special angles, let's go ahead and find the radian measure for our other 2 special angles, the 30 and the 60. I'm going to start off here with our friend 180 and think about, if I'm at 180, how do I get to 60 mathematically? 180 to 60. Go ahead, Nick, say it out loud. Divide by 3. So I'm going to take this side and divide it by 3 as well. Pi over 3 radians is equal to 60 degrees. How do I get from 60 down to 30? Divide by 2. So think about this. This is pi over 3. Just kind of think of it as 1/3. And then cut it in half. If you have a third and you cut it in half, what do you get? A 1/6. So I'm not going to write the 1, but I'll write the pi over 6. So pi over 3 radians is 60 degrees. Pi over 6 radians is 30 degrees. These are some things that eventually I'm going to ask you to have memorized. The sooner you do, the better. But one way that I always remember them is because they're switched. The 3 goes with the 60 and the 6 goes with the 30. Anyway, that's kind of cool. So this is sort of like a nice little cheat sheet for some fast, special angles in radians. Remember, what's a radian? What's it good for? Who knows? What do we use radians for?
To measure angles.
Say it again?
To measure.
To measure an angle. The same thing as degrees. Okay? And there's actually lots of benefits to measuring things in radians. For right now, though, I'm satisfied with you knowing what a radian is, and then for the rest of the class, we're just going to take some measures in degrees and convert them to radians, and take some that are in radians and convert them back to degrees. All right? Let's go ahead and do that together. over here, I'm going to write our go-to formulas. You can choose whichever one you want. 2 pi radians equals 360 degrees, or pi radians equals 180 degrees. Those are our conversion factors. 2 pi is 360, pi is 180. So number 1 here says convert 450 degrees to radian measure in terms of pi. Okay, so I'm doing a conversion. We are going to now solve this problem using the ancient art of conversion. You may remember it from yesterday. What we do is we write whatever we're given over here, 450 degrees, then multiply it by some mystery factor there, and then we will say that equals something in the number of units that I want it to be in this case, radians. Did you do any sort of conversions like this in maybe chemistry? Yeah, you did. Normally there's a whole lot of other little scale factors. Okay, I want to get rid of the degrees, so I put the degrees down here. All my final answer in radians, so I'll put radians right here. That tells me what goes where. I can choose, which do y'all like, 2 pi over 360 or pi equals 180? Y'all's preference? You will eventually. I prefer this one because it requires less reduction. That's what I'm going to choose. Pi radians equals 180 degrees. So now you can see the degrees will cancel. And we could just type this in the calculator. 450 times pi, enter, divided by 180, enter. Except that we don't want you to do that.
Yeah, I was exactly like that.
I know, I was like,
Had to wait. Alright? So the thing is that they tell us they want our answer in terms of pi. Okay? So that means don't multiply pi times all that stuff. Just leave it over here as a multiplier.
Oh, so we would just.
So all you worry about is the 450 divided by 180.
2.5.
And let's go ahead and turn that sucker into an improper fraction. 5 over 2. So we've got 5 over 2 times pi radians. You're like, that's such a weird answer. It's hard for me to understand exactly what that is. I know, it is. And it's 2.5 times pi, so it's 2.5 times 3-ish. So it's like around 7.5 something. It's, yeah, a little bit more. But that's okay. This is what they want. Okay. Unfortunately, though, we're not totally finished. It is customary not to write improper fractions times pi. What we actually do is we turn that pi into a pi over 1, and we do the fraction math, multiply it straight across. 5 times pi is 5 pi. 2 times 1 is 2. And we write it like this. 5 pi over 2 radians. And that's the proper way that pre-calculus students everywhere would solve this problem and give their answer. Okay? I'm going to skip number 2 for right now. We're going to go number 3. You might be able to look at your cheat sheet that we just did to make sure that you know how to do it, but I want to do this again just for fun, the way that we had it. This says negative 60. We really haven't talked too much about negative angles quite yet. Negative angle. We will next week. But for now, let's just leave the negative in front of it. So negative 60 degrees times some mystery scale factor is going to equal our answer in radians. I want to get rid of the degrees, so I put degrees down here. I want my answer to be in radians, so I'll put radians right there. I go to my conversion factor here, or my conversion rule. Pi radians equals 180 degrees. Leave the pi out of it and just do negative 60 divided by 180. and then go math enter on that sucker. Negative 1 over 3. Once again, not the final answer. Go ahead and multiply the numerators. So we have negative 1 times pi, it's just negative pi, over 3 radians. Like I said, you probably could have figured out that was the answer based on the fact that we just found that 60 degrees is equal to pi over 3 radians. So negative 60 is surely negative pi over 3 radians. But I wanted to make sure that we could handle the conversion. Also, students really get tripped up because they want to put the fraction times the pi. Don't worry about that. Just smash that sucker together. Numerators and denominators. Any questions so far? All right, let's deal with the variation on that, and that is converting the radians to degrees. So once again, we will write the units that we are given, negative 5 pi over 3, times some scale factor to be determined, equals whatever we want the units to be, so degrees over there. Somebody tell me what value am I going to put down here in the denominator, or what units? Radians. In the numerator? Looking at my scale factor, what number am I going to put here in the numerator? 180. What number in the denominator? Yep. Now don't get calculator happy just yet, because your calculator might make a little rounding error on the intermediate calculations, or just it will round, not necessarily an error. I'm seeing something. Pi divided by pi is 1, so those are gone. It's good news for me, less typing. Now we can just keep going. I mean, if you wanted to cancel out the 3 and the 180, you have 60, whatever, you can. But negative 5 times 180 divided by 3 equals? I'm hearing negative 300. Agree, disagree? I see the heads nodding, bobbing. Negative 300. So actually, this one's a little bit easier because you don't have to mess with all that fraction pi stuff. That's not too bad. So it's literally just a conversion. Almost makes you want to write a program to do it for you. Now you're going to love this. I've saved the easiest ones for the end. Math teachers never do that though, right? They always put the harder ones at the end. I put the easy ones at the end. You're going to love these because I tell you just round your inch to the nearest hundredth. So you can literally just type everything in and be good to go. Observe. This one says convert negative 1.6 radians to degrees. Round your inch to the nearest hundredth. So negative 1.6 radians times some scale factor. We want that in degrees. So it's literally the same song, second verse. I want to get rid of rads, put rads down there. I want degrees, I put degrees up there. Look over here at my conversion. 180 degrees is pi radians. And no need to worry about fractions, no need to worry about keeping pi. Just type that sucker in. Negative 1.6 times 180 divided by pi. Enter. Round to the nearest hundredth. Call it out when you have an answer. I'm hearing negative.
No, wait. 7.7.
Negative.
Negative 91.72.
91.72. Flip it over so you right. That's saying that is indicating that we are not right. Anybody got something different?
Negative 9.1. mean, negative 91.67.
Okay, I like the 0.67 better. Yep.
Do we have to go back to the?
Oh, degree and radian mode on your calculator only are affected when you do sine and cosine. They do not affect multiplication, division, addition, or subtraction. They just affect the trig ratios. When you're doing sine, cosine, tangent, inverse sine, inverse cosine, inverse tangent. Okay? Multiplication, that always is going to stay the same. Okay, so what I want you to do as a table, try to do one more problem. It can be 5 or 6. Call me over and give me a thumbs up if you get the answer right. And we need to work on putting these calculators back in the proper location. While they're doing that, I'll just wrap things up and say today we talked about radians. They are a new way of measuring angles, different from degrees. We found out that we like to use pi a whole lot of times when we talk about radians. And 1 radian is about 60 degrees, technically 57.3, but about 60. All right, thanks for watching.